if you haven't watched video 6.1.4, please do so before you watch this one, as it is a follow-up video. Okay, so in this one, we are going to determine the point where the gradient of the tangent. Let me not rush. Let me get my pen. So let's see. We basically looking, they want us to determine a point. Ne? So which means we're looking for x coordinate y, because they say determine a point. Remember, a point, it's x coordinate y. Okay. Where the gradient of the tangent to this curve is that. Ne? So they give us the m here. Right. Okay. So we can easily answer the first question. Remember, we said the gradient of the tangent, which is m tan, is basically the derivative of a function. In this case, it will be the derivative of f, right? And then we both have solutions for the left and the right. They gave us the m of the tangent to be 5. So the m of the tangent, we put 5. We can get the derivative of this from there. Remember, the derivative of constant is 0. This one here is going to give us minus 6x. All right. Remember, it's going to be negative 3 times 2, which is that, and then 2 minus 1, which gives us that. So now here we're going to divide both sides by negative 6. Therefore, x is going to be negative 5 over 6. Right. So we now know the point of contact between the curve and the tangent. We know the x value, right? So, okay, if we know the x value, which is the input, we can replace all the x's on the function with that x value. And it's going to give us the y value, right? Which is minus 5 over 6. Over 6. You can see what I did, ladies and gents. I got the x value, which is then there. So I basically rewrote this, but replacing the x value with what the x value answer is. Now let's press that on our calculator and see what it's going to give us. No? So we get the answer to be minus 13 over 12, which is basically your output, which is the y value. Therefore, the first point you're looking for, it's minus 5 over 6, coordinate negative 13 over 12. Right. To show that you understood this, please pause the video and try question B on your own, and then resume and see if you got the answer correct. Okay. So we're going to now go to B using the same technique that we used on A. So on B, we are basically given that the gradient is that. Ne? So we know that, okay, m of tangent is basically the derivative of the function, right? Which is g of x. So I'm going to say g prime in this case. I'm given that the m of the tangent is 0. So I'm going to have 0. Let's derive the graph. 2 times 1 over 3 is going to be 2 over 3x. And then the derivative of 2x is 2. The derivative of 1 is 0, which is the derivative of a constant. Now let us solve for x. I'm going to take the 2 that side, which is minus 2. Then we have that. Then this gives you, I'm going to multiply both sides by 3 first. Why? Because this 3 must cancel with that one. So I have negative 6 equals to 2x. Then I divide both sides by 2, which is basically negative 3 equals to x. So I have the input now. The curve and the tangent are meeting at x value equals to negative 3. Now I can replace this with negative 3 to get the y value on the curve, right? So g input negative 3 is the same as 1 over 3 input negative 3 squared plus 2 input negative 3 plus 1. I'm sure you see, ladies and gents, I just copied this, but replacing all the x values with this guy here. Right. Now let's see what that is going to give us. Let's see. That gives us -2. Therefore, the point where the graph and the tangent meet is going to be -3, which is your x, and then your y, which is -2. Okay. Now let's move to the next example. Where's the next example? Perfect. So in this case, we need to be really careful now. They want us to determine the points still. They want us to determine the points. So we know that we're still looking for x coordinate y, right? Of this function. Okay, let's firstly remember we don't need brackets. So I'm going to expand that first. So it's going to be 2 minus 1, then 2x minus 1 again. Then if you were to FOIL this, it's going to simplify to 4x squared minus 4x plus 1. Okay. So the f of x that we're going to use is when it's in this form. Always when you have brackets and you're in calculus, make sure that each term is separated. So we have 3 terms in this case. Okay. Now let me just also do the derivative of that. The derivative of this function is going to be 8x minus 4. I'm sure we can all see that. Right. Now that I have a derivative, which is the gradient of the tangent, do you agree? Sharp. Now I can go to my questions. On A, they want us to determine the point where the tangent is parallel to the line, this line. So this tangent is parallel to this line, which means the m of the tangent is 4. Remember, parallel lines share the same gradients. So if they tell you 2 lines are parallel, you have to pick that the gradients are the same. So which means m tan equals to 8x minus 4, as we wrote it there, right? But the m of the tangent in this case is 4, which is 8x minus 4. If you take minus 4 that side, you get 8 equals to 8x. Therefore, if you divide by 8 both sides, we can see that the x value is going to be 1. Right. Now, we can substitute. I always advise you to substitute into the original given one. So we're going to look for f at 1 to get the y value, right? So I'm replacing this x with 1 and that x with 1, which is in bracket 2 in bracket 1 minus 1 squared. So it's 2 minus 1 squared, which is 1. Therefore, the first point is going to be the x value, which is 1, and the y value, which is 1. Then that's finito with A. Now let's try B. Pardon me with that. Let me try to make a nice line. Okay. Okay, perfect. So on B, they say the tangent is perpendicular to this line. Remember, this line is not written in the standard form. Let's write it in the standard form first, and then we can analyze it from there. Okay, so I have 2y is equals to minus x plus 4. I'm sure you can see that I move this that side and that side. And then I divide, remember here there's a 1, so I divide both sides by 2. So I have y equals to minus 1 over 2x plus 2, right? Perfect. And then they told me that, okay, I'm going to just erase this part here. Let's remove this part. Okay. Awesome. Then they told me that the tangent is perpendicular to this line. Remember, as we said earlier on, we said if 2 lines are perpendicular, this is the m of the line, then it's not going to be the m of the tangent, because if they're perpendicular, the gradients has to multiply to -1. So which means, therefore, m of tangent in this case is always going to be the opposite of this one if they are perpendicular. So this is positive. I mean, this is negative. The tangent is going to be positive. Ne? Then this numbers goes up and down. So it's going to be 2/1, which is just positive 2, basically. 2/1. I flip them, you see? So which means m of the tangent is 2. So we're going to have 2 equals 2. Now we're doing b here. Ne? Remember, the curve didn't change, so we still use this derivative of the same curve. Ne? 8x minus 4. Then you take the further side, we can all see we're going to have 6, because it's going to be 2 plus 4. Then divide both sides by 8. Then you get x equals to 3/4. Now we're going to look for f at, we put 3/4 here and there, right, where the x are. So I'm looking for f at 3/4, which is going to be equals to, in bracket, 2 3/4 minus 1 squared. This one has fraction. Let's quickly use a calculator to save time. 3/4 minus 1 squared. The answer gives me 1/4. So this is the y value, that is the x value. Therefore, we can see that our point is 3/4, coordinate 1/4. And that's finito with this video, ladies and gentlemen. Don't forget to hit the subscribe button and to share with family and friends and to like the video. Thank you very much for your time. Aluta continua. Tango.